Welcome to today's coffee lecture about electronic laboratory journals, and I will give you a short intro into the topic and do a quick comparison of some of the systems that are in use here at ETH Zurich. And I want to start out with maybe the classic way, which is, of course, the good old notebook on paper that many of us have been using or are still. It's cheap and easy to use. It's also very flammable. If you're lucky, it might survive the fire in your lab. It may disappear at the most important moments. If you spill your coffee on it or misplace the squirt bottle of acetone, then maybe it looks like the one on the right, which is the carbon copy from the left one. It can be a nightmare if you have to search what somebody has done 15 years prior in the same research group. And so sometimes you may need to reinvent the wheel because you just don't find the information. Now, I want to contrast this with an electronic laboratory journal, and there's ups and downs. So let's start with the plus side. Your writing should become faster because you already have a digital version of what you produced. So assembling your supporting information for a paper should be quicker. If you work in several physical locations, or if you have a lab where you cannot easily take in and out stuff like a radio lab, high-level biosafety lab, then this really might be the solution or the way to go. Access control is an issue. Maybe you liberally want to share within the group. Maybe you have projects that just a few people should have access because maybe it's a collaboration with a company and confidentiality is higher. Maybe you want to track the changes that are made to the experiments so you can see what was changed or added when. Maybe you closely want to collaborate and it should be very easy to share experiments and protocols. And it would be nice to have a collective memory of what has been happening in the group so you can search it and find it again. But of course, there's also downsides. One of them is, of course, cost. Because typically this doesn't come for free. Either you have to pay a license for software, or if it's free software, you have to host it and maintain it and update it. You need space. You need electricity or internet. And if either of these is down, you might be in trouble because you cannot access your information. And then maybe that this whole thing works out, you need somebody to enforce a little bit the rules so things adhere to certain standards. There is always the risk that a company that you buy a product from decides, oh yeah, we're not going to continue this. The user base is too small. It's not worth it. And then what do? You will have to migrate your data somewhere. And so now here I have a short list of products that are used within several departments at ETH Zurich. So OpenBIS is a solution that is developed actually here by Scientific IT Services. It came out from biology. That's also why it has a certain strength in that area. It's a bit less optimal for chemistry, especially if you want to work with chemical structures, because this is a feature that's not implemented there. Then second in line is Chemotion, which is also an open source product, which came from the KIT University in Germany. And now it's been taken over by the NFDI for Chem, which is a national consortium for research data infrastructure. And so there is a lot of money going into development and maintenance of this product. Then the third is Signals by Revity, and those who are chemists among you might know the company Revity from ChemDraw, which is owned by them, and therefore, of course, ChemDraw is very nicely included or how do you say, integrated into Signals, and that's something that many people are looking for. Then we have eLab FTW, which is also an open source solution, which is maintained by DeltaBlot, and which is really a multi or a rather general ELN. So it's not specialized on anything, so maybe it lacks certain feature that you might want to have for your specialized use case. And then finally, Benchling, which is also a commercial solution, is highly focused on biological sciences and has a lot of add-ons that you could also license to fulfill your purposes. So I want to show you a few screenshots of what this is. So here we see OpenBIS, and many of these ELNs at first glance look very similar. So you have here, for example, on the left side, some navigation tool, and then on the right side, you have different fields where you can enter things. Some of them are plain text fields where you type something. You can have an HTML field where you can write longer text. You can copy in spreadsheets like the Excel, or as we see here, for example, some curve that you have measured. And you can, of course, add both the visualized curve, but also the primary data. Then the second one I want to show you is Chemotion. That is one that also offers a version that you can try out yourself online. And so here I have an example. So this is really focused heavily on synthetic chemistry, and typically the unit is a chemical reaction, although there is some functionality to also work with well plates and have some free text entries, but mostly really this came out of chemistry. You can see here, for example, I have some starting material, some desired product. I add my reagents, and then I can calculate the stoichiometry here, and then below fill a text field with the procedure that I've run. Then the next is signals, which we have available since last summer here. And this is very similar to what you can do in Chemotion. You can organize your things via drawing in a reaction, then the data get excerpted. You can do a stoichiometric calculation, and you can also add the text. But maybe slightly different to what we've seen before with Chemotion. Here you also have a lot of functionality that's maybe interesting for biologists. So if you work with sequence data, if you are, for example, a user of SnapGene to work with this kind of data, that can be integrated into Signal. And you can also use this to manage your sequence, your plasmids, and some other data that you would have maybe in a more molecular biology oriented lab. Then ELAB FTW, here I cannot show you so much in the sense of screenshots because I'm not using that product so much. I only know of one group in the material sciences that use this, but they are happy with it. And so I still want to point it out. And I've tried it here with the chemistry template that was within the software. And I saw that there isn't really much chemical functionality. I think you can draw a molecule and maybe save it in a machine readable format, but it's not as sophisticated as the other two chemistry dedicated tools. So maybe if you work in an area of chemistry where structural formula are not that key to your everyday workflow, then this might be something for you. Also because it is open source and it has various other plugins. For example, it also has a scheduler functionality. So if that's an issue that ails you within your group, that you have certain devices that are very popular and you sort of need to allocate the time. So many of these ELNs also offer work tools like that. And then finally is benchling, that is highly biological. And here you also have really a lot of specialized add-ons for biological purposes that you would probably need also to pay additionally if you want to use them. So there's always a downside to that. Then I have a small overview, and I just want to compare and contrast some points. The hosting is always, where is your data? Some of the system, OpenBIS, Chemotion, ELAB, you would host on a dedicated server, some of them Linux virtual servers at ETH. Signals and Benchling are cloud softwares. That's also the two commercial providers. With Signals, we know that the data would be on a German Amazon server. With Benchling, I cannot tell you. You also see that not all of them have chemical drawing capabilities. For 2 of them, we can have ChemDraw integrations. For others, it's other sketching tools that might or might not be an advantage or disadvantage. Not all of them can deal with sequence data. For example, ChemMotion cannot. And then the prices also vary. Signals, we have a per person license. So if you're an employee, so doctoral student level, postdoc, and other kinds of stuff, it's 50 francs per year. For the students, it's free. Benchling is a bit higher for an annual license, and you will need to pay that for every member of a research group that uses it. And you also see that for the other solutions, you have hosting costs that can be different. So the costs are really variable, but there is always some cost that you have to bear. Some of them can be highly customized. So typically the open sourced ones that you self-host, whereas if you have the off-the-shelf solution, maybe you have additional modules that you can license, but they are not included per se. And that is also the pleasant aspect. All of them have fair data, so you can export your data again in a format that you can reuse and make it findable and use it for other purposes. And with that, I'm almost at the end. I also, if you are interested in the topic of electronic laboratory journals, I want to highlight this book. I will just also copy the link in the chat. There is also for the German-speaking people really an extensive ELN, let's call it pathfinder, wayfinder, that sort of nudges you what aspects you should maybe think about. And then there is a coffee lecture card where I summarized some of the points about these solutions. And then I hope I see you again tomorrow when Roman Schurter is talking about Leganto, a tool offered from ETH Library to offer to curate reading lists, reading material, study material for your courses, and also integrate them nicely into Moodle. And with that, I'm done for today. I will copy the info for you. And then if you have any questions, please feel free to ask here in the audience or unmute yourself if you're joining online. Yep. Mm-hmm.
Especially for stuff like crystal blue. I describe it as orange. The other one is orange, and the next one is orange, and they're all a different shade of orange. Pictures are kind of helpful, and they told us linking should be possible, but somehow they don't.
Okay. Okay, I quickly repeat the comment or question also from the audience that they are a user of ELAB FTW and they are told to keep images down to a minimum. Is that for space requirements? Yeah, for space requirements. And that this can actually be problematic because, for example, when colors of crystals are written down as orange, maybe 3 crystals can be very different kinds of orange, and that's hard to assess then if it's exactly the same or if the next batch of something is different. And also there seems to be some trouble with ELAB for linking different experiments. So that may be for the audience to know. Let me quickly see what's in the chat. Yeah, I maybe know too little of these very specific questions. One thing that I would now advise maybe with yeah, things like you have crystals. Well, do you just need the color? Maybe you can have a really small, like a small image where you just to grab the color, then you could still compare it if it's about that. Or you make the pictures lower resolution, then you still have the color information and the size gets smaller. but typically a system should manage normal size images. I mean, there are other groups, they work with the video and then they quickly have terabytes of data and somehow need to, and their ELNs generally are very ill-equipped. So if you have gigabytes per day, it's already a bit of an issue. It could also be with, because many of these ELNs work via a web page. And then if you want to upload a gigabyte, it can be trouble. OpenBIS has implemented a system where you can do that via some specialized website that you can run sort of separately from doing anything in the ELN. Yeah, with others, it's not so clear. And I'm also generally more in favor of keeping the ELN as, oh yeah, I keep labels there for my primary data, but maybe keep the data somewhere else in a folder system, especially if you have to upload it all from a website. And then imagine if you have to migrate out again, then you need to pull it all. And I just think you would want the data as much as possible just within ETH. I think it's easier to deal with that. And then there is one question from online, if there are specific requirements from ETH to lab journals. There aren't really, or not per se to lab journals. There is a very general guideline to research data that you can find in the Rechtssammlung of ETH. And that is something that can give you some rough guidance. But I think it's not technical in the sense of what you need to do with an ELN, but more, yeah, how long do you need to keep data? What are the rules there, and what is expected? So it's rather broad and general, and I think it also leaves a lot of freedom, which is important because type of solution for an ELN you want for a research group really depends on what kind of research do you do, what are your specific requirements, what are must-haves, what are no-goes, and yeah, that is something you really need to think about. And maybe one last comment, and then I'm done here, is that the more interdisciplinary a group works, or the more different the projects are, the more difficult it is to find a solution that fits all. And you might even need to have two different systems. And I know of research groups who do that for exactly that reason. Okay. Any other comments or questions? Then, yeah, thank you for your attention. I hope we see you all